substitution reactions. In a substitution reaction, an atom or a group in a saturated organic compound is substituted with another atom or group. Haloalkanes can be prepared from alkanes using this method. Here, X is a halogen, like fluorine, chlorine, bromine or iodine. When chlorine is added to a saturated hydrocarbon, like methane, in the presence of sunlight, a hydrogen atom is substituted by a chlorine atom, giving chloromethane. On further substitution, another hydrogen atom gets replaced by chlorine, giving dichloromethane. This process of substitution of hydrogen atoms can continue further, until all of the hydrogen atoms are substituted by chlorine atoms. If an alkane with more carbon atoms is chosen, there are two possibilities. In propane, a hydrogen atom bonded to a carbon atom at the end of the chain can be substituted. Alternatively, a hydrogen atom bonded to the central carbon can be substituted. Hence, different products are obtained. The second type of substitution reaction is the interconversion of alcohols and haloalkanes. A haloalkane is formed when an alcohol reacts with hydrogen halide. Here, 2-methylpropan-2-ol reacts with hydrogen bromide to give 2-bromo-2-methylpropane. This reaction takes place at room temperature, if the hydrogen halide is either hydrogen chloride or hydrogen bromide. The alcohol that is used in this substitution reaction has the hydroxyl group attached to the central carbon, which is attached to 3 other carbons. This is a tertiary alcohol and quite reactive. Alcohols are classified as primary, secondary, and tertiary, depending on the type of carbon atom to which the hydroxyl group is attached. In the first alcohol, the hydroxyl group is attached to a carbon that is at the end of a chain. The carbon atom is called a primary carbon atom, since it is bonded to one other carbon atom. The alcohol is called a primary alcohol. In the second alcohol, the hydroxyl group is attached to a carbon that is in the middle of the chain. The carbon atom is a secondary carbon atom, since it is bonded to 2 other carbon atoms. The alcohol is called a secondary alcohol. In the third alcohol, the hydroxyl group is attached to a carbon that is in the middle of a chain, and the carbon atom is also attached to a methyl group. The carbon atom is a tertiary carbon atom, since it is bonded to 3 other carbon atoms. The alcohol is called a tertiary alcohol. Primary and secondary alcohols react slowly and at high temperatures. Now let us consider the conversion of haloalkanes to alcohols. A strong base, such as sodium hydroxide or potassium hydroxide, is used. A dilute solution is necessary in order to achieve hydrolysis of a haloalkane to give an alcohol. Here, 2-bromo-2-methylpropane reacts with sodium hydroxide to give 2-methylpropan-2-ol. The haloalkane must be dissolved in ethanol before treatment with aqueous sodium hydroxide. The mixture must be warmed but not heated. The same hydrolysis reaction of haloalkane can take place without using an alkali. The reaction will be much slower. Care must be taken that the base is not concentrated, as an elimination reaction will occur in that case.
Starting to feel it? Now go master it with Maskitv.